Well, howdy there, Internet students. Mr. Hermanson again. Hey, this is lesson 9.1e. Well, we're going to learn how to use flowcharts to represent solutions to equations and problems. So um, let's look at this problem here. In preparing for a party, Maya bought 5 bags of bagels and 4 extra bagels. So we're going to let n be the number of bagels in a bag, which we don't know right now. But if n represents the number of bagels in a bag, then the total number of bagels she purchased is 5n plus 4. Okay? To find the total number of bagels, you multiply the number in each bag by 5, and then you add 4. We can show that with a flow chart where the number of bagels in a bag is the input. We're going to multiply that by 5. And so that ends up with 5 times the input, or the number of bagels in a bag. Then we're going to add 4, because there's an extra 4, remember. And this will give us the total number of bagels. Okay, notice there's arrows, so we know which way to go to get to the output, from input to output. And each arrow is going to represent some mathematical operation. Okay? So if we input 3, so I put 3 where the original n was there, right? Then we would take that 3, multiply it by 5 to get the answer there, which is 15, and then we would add 4 to get the answer there, which is 19. Okay? In the next 3 problems, you're going to use a flow chart to find outputs for the given inputs. Go ahead and do the operation. So this is your input. You're going to multiply that by 4, put the answer there, which is 32. Then you're going to subtract 5 and put the answer there, which is 27. Go ahead and do the other. All right, here's what I got for that. Oop, this is wrong. This should be 4.6 repeating. All right, so you saw how the operations were in the flow chart. So now we're going to have you create a flow chart. All right, I'll help you out and maybe do the first one with you. We're going to do 2 different expressions. I'll do the first one, and then you can do the second one to try and think of how your flow chart would be different. But so this is going to be our input, which is y. And then we're going to go to the next oval by doing the first operation here, which is times 6. Okay, so then this becomes 6 times y. And then we go from that by doing the second operation in this order, which is plus 1. And that gives us our output, which is 6y plus 1. Okay, now since you might want to put a number in for that y, you don't necessarily have to write all the expressions along the way. But in the end, you should end up with that expression. All right, so think about what the parentheses would do. Make your 3 ovals. Think about what you do first, what you do second, and in the end, you need to get this expression, 6 times quantity y plus 1. Go ahead and try that. All right, so this time you should have added 1 first and then multiplied it by 6. All right, so consider these 2. Remember that when you have a divide sign like this, it's telling you to add that 2 first and then divide by 3. So go ahead and draw your circles. Make sure you're going from the input to the output. And go ahead and do these 2 problems. You've probably noticed that you really only need 1 oval to go to on the second one to get the n plus 2/3. That goes in this circle. All right, so use your flowcharts to find outputs for 3 or 4 n values. Do both flowcharts give the same output? So in other words, it's asking you to pick 3 or 4 values to put into both of these, and then to answer the question. So go ahead and check that out, see if you get the same answers. So I used an input of 7, and I definitely did not get the same answers. When I put in 7 in this first one, I ended up with 3. When I put 7 in the second one, I ended up with 7 2/3. And the reason is because you're doing the operations in a different order. So the order matters a lot of times. All right, so Maya had 5n plus 4 bagels. We remember that from the beginning. Suppose she had a total of 79 bagels. Okay, in other words, that's the output for this. And we actually get this equation, 5 times the number of bagels in a bag plus 4 equals 79. So remember we had this flow chart for Maya, and we ended up, now we're saying that the output is going to be 79. Now what I want to do is go backwards, so think about what number you would add 4 to get to 79. And that number would be 75, and you can get that by doing the opposite operation or inverse operation. Do 79 minus 4 instead. And sometimes I even put that down here. So it's the opposite. And then we're going to go back to the very beginning, what she would have started with if she ended up with 79. So we're trying to think of what number times 5 is 75. And we're going to do the opposite of that operation, which was times 5. 75 divided by 5 is 15. So an input of 15 would give you an output of 79, and we just solved this equation. So the answer was n equals 15. All right. So the input Leon found, 15, is a solution to this equation. Now you would practice solve equations. Okay. So Libby put an input into this flowchart and got the output 53. And so use backtracking like I did. So what I do is I think about what's going backwards from this plus 5 here, and I do that to 53. So 53 minus 5 is 48, and this says times 4, so going backwards I would want to divide by 4. 48 divided by 4 is 12. All right, so each of these flowcharts represents an equation. Now the equation is, you're going to think of this first box, your input, as being x. So we're taking x times 3, and then we're going to subtract 7, and it's going to equal 26. Now to find your solution, you're going to go backwards. So write down what going backwards would be, so you are reminded what to do. So I'm going to take 26 plus 7 to get this number. Just make sure that works there. So 33 minus 7 equals 26. And then we're going to divide that by 4. 33 divided by 4 is 8.25. And then just to make sure you're right, you just take this times 3, subtract 7, and see if that gives you 26. All right, why don't you try? So our solution is our input there, which was 8.25. Why don't you figure out what equations are written here and what the solutions are? All right, here's what I got for those. Now on this one, notice you have parentheses here, and that's because of the order you're doing this. You start by multiplying by 3, then you subtract 1, so that gets done first, so I put that in parentheses, and then I multiply that answer by 2. All right. Now I didn't need parentheses here because when you write division like this, it automatically means parentheses. All right, so now that you have some experience using backtracking to solve problems, you can use backtracking to solve more challenging problems. So, so Lakeisha is thinking of a number, so that's your input, doubling it, adding 3, multiplying your result by 10 to get an answer. Okay, and Mateo's output is 210. So to draw a flow chart for this game, so this is your input where Lakeisha says think of a number, take that number, double it, which means times 2. That gives you a new number. And she next said add 3. And that gave you another new number. Then she said multiply that result by 10. So times 10. And she says, what do you get? So there's your output. Okay, and you know that Mateo's output was 210. So go ahead and answer the next 2 questions. What equation does your flowchart represent? And use backtracking to find the solution to figure out what Lakeisha's number is. All right, here's what my equation looks like, and backtracking, I get this answer. All right, so go ahead and draw a flow chart for this algebraic expression. I'll get you started here. So n is your input right there. The first thing you do according to the parentheses is you add 1, so that'll get you to the next number. Then you're going to have to multiply that number by 2 next. That'll get you to the next number. Then you're going to have to divide that answer by 3. That'll get you to the next number, and then the last thing you do is subtract 1. Seems kind of complicated, but when we do it like this, it kind of seems a little simple. Now, go ahead and backtrack on that to find the solution to when the output is 5. So start with 5 here at the output, and then work your way back. All right, did you get 8 for that? Go ahead and try these 4 problems. Make a flow chart and backtrack to solve for them. All right, here's what I got for those. All right, so when we solve a word problem, what we're going to try to do is write an equation to represent that word problem, and then using a variable to represent the missing amount. And then we can use the backtracking thing to help us get the answer. So Drake has his business. He charges $15 for mowing the lawn and $2 for every window he cleans. So that equation would be it's a charge for one person's house, it would look like this. $2 times however many windows he cleans. I'll use X for that. And then plus the 15 he charges for mowing the lawn. And he got $37. Okay. Now, if you're wondering how many windows he cleaned, you're going to work backwards. So we're going to set up this. And first thing you do is multiply by 2, and then you add 15. And then his output is how much he gets, which is 37. Go ahead and backtrack that to get the answer. So I hope you got 11 for that one. I'm going to let you try this, read the question, see if you can come up with the equation for it, and then backtrack to find the solution. All right, here's what I got for that. Now, what you can do, go ahead and summarize what you've learned here, and try some of them homework problems. And if you have issues with that, go ahead and send me a message. We'll see you soon.